Should I continue?
Yes.
This is the basic Zoom I do have. That is why I think so. It is limiting my uh, lecturing time. Okay. All right. So, what is the condition for if? Well, condition for leap year is if I is divisible by 4.
Doctor,
Yes,
sorry for interrupt,
yes, yes.
but there is a problem. It's happened. All of us are left because I'm not sure, but
Well, because I was using basic feature of uh, Zoom, and individual time is only for 40 minutes.
oh,
I think there were how many? 5, 4 or 5 hours. Should I write it? Students connect with same. Okay. All right. So we are saying that it should be. We are saying that it should be divisible by 4. And it should.
4 or 2, sir.
Pardon?
4 or 2.
4, not 2. Leap years come after 4 years.
Okay, I didn't read the question.
Okay, this is one condition. It should be divisible by 4 and should not be divisible by 100, or it should be divisible by, I should be divisible by 400. Okay, so if it is the case, what we need to do? As out, I should write it. I give a separation. Further, I should increase both counters. Num per line, because we have printed a number. Num per line, okay. Line plus plus, and also we are trying to keep track of number of leap years which have passed. So we should increase this also. Okay, but the question also says that only 10 in a line. So after the if, what should we do? Or even here, if num per line is divisible by 10, what should we do? we should simply change the line. Why I have written? I have written it just to change the line. Just to change the line. Okay. When the for loop finishes, here I should write total number of leap years equals how much? Count leap. Let's run the program and see the result. Look here, these are the leap years. 4, 8, 12, 16, 120, 24, 28, like this. Okay. And the total number of leap years is 485. Well, I should use a new line so that it appears into new line. Okay, so total number of leap years are 485. Okay, students, any problem? Anything?
All good, mister.
Okay, so let's
Hard a little bit.
pardon.
It's a hard a little bit.
I think it is network connectivity. You are not good, very good audible here. I'm not able to understand what are you asking for.
He's saying it's hard.
Oh, it's hard. Not very hard. Just you need to remember the techniques you have learned previously. Okay. Well, these are all things here we have solved previously. These series are very nice. They give very perfect understanding of what uh, loops are, and with the loops of how we can solve the algebraic problems with the help of loops. All such linear combinations, like series sequences, can be solved with the help of loops. But just to maintain the simplicity, I will skip them. Now look here, students. This is again a good question. 5.37. 5.37 is saying decimal to binary. Write a program that prompts the user to enter a decimal integer. Okay. And displays its corresponding binary value. Don't use Java's integer to binary string in this program. Okay, we should not use this method given in the integer class. We should write by our own how we can convert decimal into binary. Okay, how can we do this, students? Any idea about? Any idea about the? No idea? By the way, why are you not speaking, dear? Look here, students, this is Jamboard. Okay. I think you can see the Jamboard now. Hmm? So how do we get the binary representation? For example, this is 8, which I want. 8. Hmm? What I will do, I will divide it by 2. It will give me 4. I will divide it by 2. It will give me 2. I will divide it by 2. It will give me 1. Okay. So in this way, we keep on dividing until we get 1. And for each division or each appearance of 2, we put 1. So let's say 1, 1, 1. No, we should start from here. This is 8, 1, 0, 0, 0. 1 is 0, 2 is 0, 4 is 0, 8 is 1. This is our binary representation of 8. For example, 7. Similarly, we can have 7, 2. Look here. In the 4 bytes, we say BCD. Let me tell you, BCD is like this. Okay. For example, it is A, B, C, D. So we start from, it is known as LSB, least significant bit. This is MSB, most significant bit. So what we do, we try to realize a given number in this. This represent D into 2 to the power 0. This represent C into 2 to the power 1. This represents B into 2 to the power 2, and this represents A into 2 to the power 3. Okay. Now if I need to represent 7, how I can represent? We want 1. Okay. So it is 1 into 2 to the power 0 plus. This is what? 2. This represent 2 to the power 1 means 2. So we need this also. So 1 into 2 to the power 1 plus, we need this also for 4. So we write 1 into 2 to the power 4 plus, we don't want this. Okay. 0 into 2 to the power 0, 1, 2, it is 3. So ultimately it becomes 1, 1, 1. By the way, this is the just an attempt to elaborate it. Otherwise, when it comes to the writing program for converting this, it is quite easy. You can just remember the trick and it is applicable to any type of conversion. Let's see what we need to do. 38.
Assalamu alaikum, doctor.
Walaikum assalam wa rahmatullahi wa barakatuh.
Sorry, doctor, but I have to leave.
because I have another
No
class.
problem, no problem. You
Thank
can
you.
you can.
Thank you. Thank you,
Well,
doctor.
I will share the link later
Okay.
on. Okay, let's start with PSVM. Scanner in equals new scanner. Okay. What is expected? User enters the number. User to enter a number. Okay. So let's give a message to the user. Enter a decimal number. 1. User will enter a decimal number. Let's collect it somewhere. Integer, decimal, contact equals in dot next integer. Okay. Now we have a decimal number with us. What do we want? We want to convert this number on the binary numbering scheme or the base 2. We want to convert this into on base 2. So what we will do, we will simply write for or even better than for, right? While dot 2 remains greater than 1. What should we do? In between, take a variable, let's say string string is binary. Let's say binary equals, we do have an empty string. Okay, so what should we do? Binary equals, or let's say binary plus equals decimal modulo 2. So all the divisions where it will produce remainder 1 will be added as 1, where it will produce remainder 0 will be added as 0. Okay. And again, what should we do? We should, after every operation, we should update it, or let's say we should say plus equal 2. S out, let's say equivalent binary number is for example, if we enter 7, 7. Binary is 1 1. It is missing one thing. We started with empty. We keep on unless it remains greater than equal to 1. Okay. Binary plus 2, because we want to convert it into binary number system, and then we are updating decimal as decimal divided by 2. Okay. The last bit is not coming. The last bit is not coming. Why the last bit is not coming? Again, the MSB is not coming. Okay, it checks that if it is greater than 1, okay, goes inside 8, 4 goes inside binary and decimal. Let's say 8 modulus 2 gives 0. Okay, 0, then 4. This is 2. Now we got it. Okay, look here. We got it. 8. Most significant bit was opposite of. Okay, now it is working as it should. Okay, 15 is for all bit of, let's say 12. Perfect. We can check it. If you want, you can check it. We do have some calculator. You can open the calculator. Uh, so we do have our calculator with us. For example, for 12, look here, in hexadecimal it is C, in decimal it is 12, in octal it is 14, in binary it is something like this, 1100. Let's say 14. It is 1110. Let's check it. 14. You get in binary 1110. That is what we are getting. Okay, students. So actually this is the trick how to convert a decimal number into binary number without using any special library for it. By the way, students, the next problem 38 is very similar to it. It is decimal to octal. That is to say, what is octal? The base 8. Okay. So with only one slight change, the second program can also be solved. Okay. Previously we were dividing by 2. Now because it is octal, so we have to divide by 8. And that is the only thing. Nothing else. You can change binary into octal. Wherever is binary written binary, just change it to octal. Well, I can change by my hand. Octal, 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 and octal here also. Now let's run it. For example, students, I want to check for 10. 10 equivalent octal is 12. Want to check? Open the calculator. Write 10. Look here. In hex it is A. In decimal it is 10. And then in octal it is 12. Okay. That is to say we did get what we were looking for. All right, students. Is it okay?
Yes, Mr.
Okay. By the way, students, should we go for salad break?
Yes, okay.
Okay,
Okay.
let's take 10 minutes break and we will be back after 10 minutes. Okay, I will also pray and you can also pray and come back. Okay,
Okay.
just keep in mind only 10 minutes. Okay, not more than this because we do also have a lot many things. Let's say I am fixing the timer. Let's say 10 minutes. Okay, so it is a start. All right.
Okay, Mr.
All right, students. Should we start? Are you ready?
Yes, I am ready.
Good. So where we were? This is our octal. Huh? Well, let's go to the next program. Simulation of heads or tails. Okay. Well, it is a simple program, but still I will take